We're starting out with today's topic, that is prefix sum. So, firstly, understand that why do we need to find the prefix sum? So, let's say there are t test cases that we have to figure out, and the array size is n, and we have to find the sum from a position L to R in the array. Now, for example, let's take an array as 1, 2, 3 that goes to n. And in the worst case, I can say that my L can be 1 and R can be n. So I have to find the sum of all of the elements of this array. Now, suppose that T is given as 10 to 10 raised to the power 5 test cases can be at max, and the array size can be at max 10 raised to the 4. So if we apply the brute force method here, so what will be the brute force for it? Firstly, so brute force method will be like this: while t minus minus, and then I will traverse the array for I is equals to L, I less than equals to R, I plus plus, and then I will take a sum is equals to 0 and sum plus equals to AI, and then I will output the sum. So this will be the brute force for it. But this will not work in the case when I have given these types of inputs. Well, what the problem is here is that I will be running this loop of while loop for 10 raised to the power 5 times, and this inner loop for 10 raised to the power 4 times in the worst case. Worst case will be when L will be 1 and R will be n. That is, I have to traverse all of the array all of the times. So here the time complexity will go to 10 raised to the power 9, which is greater than 10 raised to the power 8. So it will create a problem. Now this problem can be tackled by using the prefix sums. So how can I make a prefix sum array? So let's say we have the same array as we have declared earlier, that is 1, 2, 3, 4, 5, 6, 7. Let's take till this point only for just our understanding, and then we will see that how it will work. So the prefix array will be, it is at 0 position 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6. Now the first element will be copied as it is. So at 0 position I will have 1. Now at 1 position, what I will do, I will sum both of these, that is 2 and the 1 that I am having. So this will be 3 here, that is 2 plus 1. Now at this position I will have the sum of both of these, that means 3 and 3, that is 6. And you can see the second position is representing the sum from 0 to 2 position. That is, I have 1, 2, and 3, and this is giving me 3 plus 2 plus 1, that is 6. Now at 3, I will be having the sum of 6 plus 4, that is 10. At 4, I will be having the sum of 10 plus 5, that is 50. And then 21, and then 28. So I will be having this prefix array. Now, for making this, I will need only big O of n time if there are n elements. And suppose if I want to find the sum of L comma R, and let's say L will be 1 and R will be 6 here. So I need to find the sum from 1 to 6. So how can I find this? So here what I just need to do is go to the prefix of R and subtract the prefix of L minus 1. So let's see, here is it is 28 and L minus 1 is 1 minus 1, that is 0, that is 1. So it is 27. So let's see in our original array what we get by summing up the values from 1 to 6, that is 2 plus 3, that is 5, plus 4, 9, plus 5, 13, plus 6, plus 7, that is 19 and 26. 7, 6, 13, 17, 18, 22, 25, 27. Okay, yeah, 27. So I'm getting 27 here also. So that is what our prime prefix array will reduce our time complexity from big O of n square to just big O of m. So now let's just move on to the code of the prefix sum. So I've taken the input as an array. Now what I need to find is the prefix sum for it. So I will just declare another array named as prefix with a size n, and I will just loop out the array. So if it is the first index, my prefix of I will be equal to just a of 0. Else, if it is not the first index, then simply prefix of I is equals to prefix of I minus 1 plus a of I. So that's it. I have made my prefix array. Now I just need to compute the number of test cases, or what you can say, number of queries. So while p minus minus, these are all the queries. I will take the inputs as L and R, Cn L R, and sum will be equal to, let's take the int sum, and sum will be equal to prefix of R. So I'm not taking here prefix of R minus prefix of L minus 1, because if L is equals to 0, then L minus 1 will be negative. So I have to handle that case also. So if L minus 1 is greater than equal to 0, then only what I will do, I will just then only will make sum equals to sum minus prefix of L minus 1. Else, if L minus 1 is less than 0, then sum will be only equal to prefix of R, as I have done here. Then at last I will just see out the sum, and that's it. So this is all the code for the prefix sum. So what we have seen earlier is the 1D prefix array. So now let's say if I have a 2D matrix and I need to find the prefix sum array for this matrix. So let's say, for example, if I have a 2D matrix, A is equals to a 4 by 4 matrix, and the elements are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I need to find the prefix array for this matrix. Okay, so prefix. So this will be also be a 2D matrix, and let's just declare it 0, 1, 2, 3. This. Okay, so this first column will be containing this first value only. Okay, yeah. Now the second column, this second column, let me take another color. So this second column will be taking the sum of values, the sum of values in the original array from both of these. So this will be 1 plus 2, that is 3 here. Okay, so what I'm saying is that this column is equals to array of 0 0 plus array of 0 1. Now the third column will be the sum of all three values. That is, it will be including these values plus array of 0 2. So that will be 3 plus 2 plus 1, that is 5 here. Okay, and similarly 3 will be having the whole row as a sum, so that will be 9 here. Put it by another color, so this will be 9 here. Now in the second row, if I look at this column, this will be the sum of both of these values. So this will be the sum of both of these values. So this will be 1 plus 5, that is 6. Now the next column, this one, is equals to the sum of this square. 6 plus 2 8 plus 1 9 and plus 5 14. So basically what I am saying, if I want to find a column in prefix array, let's say this column I want to write in the prefix array. So what I will do, I will take this column, I will take all the values, that is making a rectangle, taking this column. So what I will write here is the 7 plus 3 plus 2 plus 6 plus 5 plus 1. So that will be 7 plus 3, 10, 12, 18, 23 and 21, 24. Now, how these values are coming? How these values are coming? That is the point. So let's take for example this 24. This 24. This 24 is coming as prefix of I j is equals to prefix of I minus 1 j plus prefix of I j minus 1 plus a of I j minus prefix of I minus 1 j minus 1. So this is coming as this. So let's take proof. So this value, that is, we need to find this value. So prefix of, so this is 1 comma 2. So 1 2 is equals to, it must be equals to prefix of 1 minus 1, that is 0 2 minus prefix of 1 1 plus a of 1 2 minus prefix of 0 1. So now let's just put the values. So prefix of 0 2 is equals to 5 plus prefix of 1 1 is equals to 14 plus a of 1 2 is equals to 7 minus prefix of 0 1 is equals to 3. So it will be equal to 18 and 23. 19, 26 and 23. So this value must be 23 actually. 7, 6, 13, 18, 19, 21, 24. What I'm okay. So I was missing this. And this value is 6 actually, not 5. Because 3 plus 2, 5 plus 1, 6. So this value will be 6 and this will be 24. Okay, so this is how I am calculating the value. So let's say for example, I will tell you 0, 1, 2, 3, 0, 1, 2, 3. This is our prefix array. If I want to find this column, if I want to find this column, then what I will do, I will take, this is 3 comma 3 comma 1, this column is 3 comma 1. I will take the prefix sum of 3 minus 1, 2 comma 1. So 2 comma 1. So this prefix sum of this. So prefix sum of this column will be this. So I'm taking the sum of these values. Okay, yeah. Now I will take prefix of I comma j minus 1. So that is 3 comma j minus 1, that is 0. 3 comma 0. So that means this. So prefix sum of this will be this. So this column is covered, this column is covered, this column is covered, but these columns are covered two times. So what I need to do, I need to subtract it one time. So I'm subtracting prefix of I minus 1 j minus 1, that is prefix of 2 comma 0. So 2 comma 0 will be this, so I'm subtracting it one time. Now I'm having the sum of this and this, but this value is still remaining. So I am adding here plus a of ij. So that is the logic behind the formula that we have driven for prefix of ij. So this is how we can make a 2D prefix array. So let us see the code of how to build a prefix array of 2D type. Okay, so let's say I want to make a new function void prefix 2D. Okay, so we have to take n cross m matrices. So I will just import the values of n and m, and for int y is equal to 0, int a and m, and I'll also declare a prefix 2D of size n m. So I've taken the inputs for the array. Now I want to make the prefix array, 2D prefix array. So for that, just loop the values less than n I plus plus for j equals 0, j less than m, j plus plus, and the first value prefix of ij firstly will be prefix of ij will be firstly equal to a of ij if none of the conditions is applied, and the conditions are if I minus 1 is greater than 0. That means we don't want to go to the negative indices. So if I minus 1 is greater than 0, then only what I will do, I will just put, okay, so this is prefix of 2D, prefix of 2D, prefix of 2D of I j will be plus equals to prefix of 2D of I minus 1 j. And if j minus 1 is greater than 0, greater than equal to 0, then prefix of 2D of I and j plus equals to prefix 2D of I and j minus 1. Okay, and if I minus 1 is greater than equal to 0 and j minus 1 is also greater than equal to 0, then I will subtract prefix 2D minus equals to prefix 2D I j prefix 2D of I minus 1 j minus 1. Yeah. So this is how we can make the prefix 2D prefix array. So hope you have understood. If you have any queries, you can comment down your queries and I will try my best to resolve them as soon